Okay. So when we say DevOps, it's not only development and operations. Developers usually do kind of coding, unit testing, and some kind of integration testing, right? For that, they require some kind of system or environment to test it. Because when we say any environment, be it development, QA, test, or stage, it is a system or it is a set of machines in which some dependencies software is installed, and that will be used for validating the application that we are developing.
Mhm.
So when uh, developer is doing some testing around that, they make sure whatever is tested in QA. Say for example, in QA he will be doing some round of testing. Maybe it's a QA environment. After that, it is stage. After that, it is prod. Say pre-prod, and then you have a prod which is customer facing, which is for the customer, right? What exactly we need in DevOps, or maybe what problem that we were trying to solve is it should be consistent. Say if it is say this one, the environment is named as this one, and then it has some set of packages. The same set of packages should be available across all the environments. Same set of configuration should be available across all the environments, so that whatever is running on this particular local dev, QA, stage, pre-prod, and it is running in prod. So we need a consistent environment across all phases of release, all environments. That's why we came up with a DevOps principle. This is not just only using tools, also automating every small piece of the operation that you do, automating each and every small task that you are doing. Um, that's why it is very popular, and then it is a very successful principle. If you take a look at Amazon, Netflix, or whichever company that you that are very popular or very successful, they are using DevOps practice in their release cycle. Any questions on this?
No, no, no. Good.
Okay. Have you heard about or have you seen what is the DevOps tool chain?
Yeah, CI/CD program, right?
Yeah, CI/CD. So basically, people think that usually the cycle starts from coding, whereas the cycle actually starts from the planning, where you create a plan. You are already working in the IT industry, so you will be aware what we do in the planning. I mean, we basically go and create tasks, and then the task will be converted into smaller pieces, and then developers will start working on the coding for a small feature, and then they'll start doing the integration, and then they'll end up creating a build. Any idea what is build here?
Build is something with the requirements that developers will build the tool.
Yeah, basically build is nothing but a package or a binary or a kind of ISO image which contains all small code modules. So these code modules will be built and then combined and then built as a build. Basically, if you can think about copying multiple files and folders and then transferring to some other person, right? What you'll do, you will do a zip and then you will package it and then give it to the other person. Similarly, whatever code is written, it will be packaged and shipped to people. That means internal people who will be testing it. Initially, it will be tested in the local environment by a developer, and then it will be released to the other people. So here the release means internal release as well as the external release. So if for the internal release, we'll do the deployment, operation, monitoring for the local environment, which will be dev, test, stage, and pre-prod. and again it will go for the plan. If there is any problem with respect to the dev environment or test or stage, it will again go for the plan code, and then finally it will be tested, and then it will be released to the customer if everything is okay. So it will be deployed to the customer environment, and then it will be operated by customer. It will be monitored by our DevOps team, and it will be again going back to the planning stage based on the review, based on the feature review. So on the left hand side, it is CI, it is continuous integration. On the right hand side, it is continuous deployment.
Hmm.
So it is DevOps is actually continuous practice where we'll be looking at small feature and start working on the features and test them and release it to the customer, so that customer is having the latest and the greatest of whatever package, whatever feature that we are developing. Any questions on this?
No, no, no. I'm good.
Okay. Have you heard of any of the tools that I have highlighted here?
Yeah, Jira, I have heard.
GitLab or GitHub?
I have heard, but I have not used it.
Okay. Uh, so one thing I told you, right? In everybody who is working in the organization at this stage with the DevOps practice, everybody will be doing coding, irrespective of
Yes.
whether he is a developer, QA, or a DevOps engineer, or a SRE engineer, or a cloud engineer,
Hmm.
because he'll be working on creating some kind of coding. For example, the infra DevOps engineer will be creating Terraform code,
Hmm, hmm, hmm.
because that is for infrastructure creation. Infrastructure creation, if you probably don't create a code base and then don't manage your code base, it will not be reusable, or it will be popular only to the guy who is developing it. And if that particular person leaves the company, the whole purpose of creating a infrastructure through Terraform, through infrastructure as code tool, will not be benefited, because I mean the code will not be managed by other people. It will be known only to the particular person. So in that case only, every piece of code that is getting developed should be managed by source code management tool, which is nothing but Git as a protocol, GitHub or GitLab as a repository server. It has one of the repository server you should be using, and Git will be your protocol to manage your source code.
Hmm, hmm.
For building, you will be using, if it is a Java based or any other .NET based, you will be using Maven or Gradle, and Docker for container based applications, JMeter and Selenium for test automation. You see Grafana, Elasticsearch, and CloudWatch. That will be for monitoring. AWS native tool is CloudWatch.
Hmm, hmm, hmm.
You talked about Kubernetes, right? Kubernetes at the operation level, where you can manage containers which are running in a cluster. You
Okay,
can
okay.
you can say how many container, how many services should be running in this particular machine, how many services should be running in this particular machine,
Hmm,
what is the replica size, what is the CPU, what is the memory utilization. So like that, there are so many different roles that you can define in Kubernetes, and you can manage your containers or pods running on the cluster. That is what Kubernetes do. It is basically an orchestration tool through which you can manage auto scaling.
what is
Uh,
orchestration?
Orchestration, right? I mean, if you just repeat the word once again, you will understand what is the orchestra that happens in the stage.
Any kind of program?
Music orchestra. Yeah, sorry.
No, any kind of program conducted on any festivals or something. You're trying to say like that.
Correct, correct. So basically, there is one person who is managing everybody, even though he is not doing any activities, right? He'll probably say, okay, this time the music should play, this time the singer should start, this time probably everybody should uh, sing, or
Hmm.
maybe that kind of I mean, there is a cooperation between different people, but there is one person who is managing everybody. So, like that, orchestration means managing the containers which is running inside a cluster. It is a single server or single service which will be managing multiple small pieces of Docker containers running inside the cluster. Uh,
Mm.
See, the operations in the orchestration will be auto scaling, deployment, monitoring. So everything related to managing the containers done by Kubernetes. The whole operation is called orchestration.
Okay, okay.
Basically, when you run Docker containers, it's a very small piece of code, small piece of software that is running, and that has no control over how long it will be running, whether it is running for 2 hours or 3 hours, or how much load it can take up. What is the maximum CPU that it can utilize? There is no guarantee of what it can utilize, because I mean everything should be properly configured while you are starting the Docker container. So it will go out of memory, it will go out of disk or your CPU anytime. So there should be another person who is managing the containers running in your environment. That is Kubernetes.
Mm.
Okay, moving on. See, when we say DevOps, there are two things I already told you. Automation is one of the main goal for DevOps. Because one of the main reason why we do automate is we want to have a consistent environment, consistent results across the release. Collaboration, you already know that it is already combination of collaboration between three different teams. One is dev, another one is QA, another one is operations. So monitoring
Yes.
and feedback. Without monitoring, without giving feedback, you will not be able to improve your system. That's why I mean this is also one of the major principle, one of the best practices that needs to be followed if you are saying DevOps.
Yes, yes.
So the key principles of DevOps: collaboration again, automation once again, continuous integration and continuous delivery we talk about, because we have to do everything in a continuous manner, be it development, be it testing, be it monitoring. Um, there are seven continuous phases. For every small operations, we prefix with continuous. Continuous
Mm.
integration, continuous deployment, continuous delivery, continuous testing, continuous monitoring, like that. Everything is continuous. When we
Yeah.
say continuous, it means we are basically making use of some of the tools to automate that particular phase. Then only the outcome of the particular action
Mm.
will be given as a feedback, and again it will be again coming back to the same. It will be going in a circle. The repeated action will be going into a circle. Okay. So see, if you look at production readiness, so we talked about how fast we can release to the customer. Uncompromised quality by having a rapid recovery from failures, testing them on time. Repeatable delivery means um, there is always a set of deliveries. There is always specified time within that. I mean, we'll be testing the product and delivering to the customer.
Yes, yes.
Yeah. Some of these things are, I mean, kind of repeating the same stuff once again and again. One of
Mm.
the most important thing is for sure it is monitoring and test automation.
Sure.
We'll be seeing monitoring, how to monitor, how to make sure, how to work on whatever issues that are coming in the monitoring. For example, auto scaling or restarting a particular server, things like that. So, like I told you, DevOps is infinite. Uh, DevOps is CI/CD. You have any idea what is CI/CD?
That is a continuous integration, continuous development, right?
Deployment, continuous deployment.
Development.
Any idea what is deployment?
Deploying the a feature to the production.
Yeah, basically it's just installation and configuration. So people,
Uh-huh.
the DevOps term, we call it as deployment, but ultimately what we'll be doing is creating the environment, installing the packages, configuring the system. That's what in total it is called as deployment. Because say for example, even if you want to install Amazon app in your smartphone or a Flipkart app in your smartphone, right? What do? You check around how much disk it will occupy. What are the different applications that it requires permissions? It requires permissions from contacts or maybe location. So all of those things you take care of, right? The whole process you can simply say that you are installing, but along with that you are doing some configuration. Along with that you are trying to take care of some of the other system properties, right? The whole thing is called deployment.
Yeah.
So when we
What is
say
it?
that,
DevOps is infinite means
so
how
infinite,
do you? Huh.
yeah. So basically, if you look at this one, right, it goes in an
Oh,
infinite
oh,
flow.
okay, okay, okay. Got it. Yes, yes, yes.
Okay. It is never ending. In fact, I mean, whatever activities, whatever uh, uh, tasks that you are doing in IT, right, it is never ending. If probably somebody says, I stopped my Windows version to 2024, right, probably other people will also be affected. Uh, on the other hand, they are coming up with new chipsets from Intel, or maybe Apple is coming up with newer version of another chipset. Like that, people start developing new chipsets. At the same time, people are developing new softwares, new operating systems. So it is never ending. Similarly, DevOps is also never ending.
Mm-hmm. Yes, yes.
Yeah, it is basically a culture. I mean, it is not something. Uh, it is a process or culture that should be understood by each and every person within the team. If somebody says I will not follow this, probably you will end up having some issues for the customer, because you will not have a consistent environment at the end for the customer. So it's
Yes.
all about automation. Bridging the gap means, I mean, there used to be kind of some confusion between different teams earlier. Developer says it is working in my environment, whereas the QA says it is failing in my environment. And QA says I have tested it thoroughly. It was working in my environment, whereas it is not working for the customer. So that kind of problem will be overcome here. All the gap will be bridged by DevOps.
Yeah,
Okay.
yeah.
Okay. So some of the tools that we'll be looking at first is infrastructure as code tool, which is nothing but Terraform. How do we create code in Terraform? How do we create resources in AWS like that? Uh, Basically, for this, you need to know a little bit of JSON format. How do you write a JSON format or YAML format? Uh,
Uh-huh.
like that. So it is a declarative language, which is called as HCL, HashiCorp Configuration Language, which is similar to JSON.
Okay, okay.
Uh,
So you'll give me that idea, right? Like the basic
yeah,
ones.
exactly. So I'm just here. I'm trying to give you what is CI, what is CD, what falls into CI, what falls into CD. Whatever you do with respect to coding and unit testing till the build creation, it is called continuous integration, because
Mm-hmm.
you create code and then I mean developer does coding, does unit testing and then create a build. So connecting coding and then creating a build, right? That process is called CI. Continuous integration means whenever the developer is ready with the latest code, the DevOps team should make sure the build is generated out of the latest code. That will happen when the developer is pushing the code to the particular repository. As soon as he pushes the code to the particular repository, the DevOps will write a piece of code uh, that is integrated to the development environment that will take care of creating the build.
Mhm.
So it's kind of a, I mean, it's not very straightforward to easily understand because within the developer code itself, we'll be writing some piece of code by DevOps, which is nothing but a small text kind of thing, not like deep coding or not like depth coding. It is just a matter of writing a one build spec file, which will take care of creating a build out of the latest code.
Sure, sure.
And continuous deployment means it starts from creating the infrastructure using Terraform. Say, for example, nowadays you get the laptop with the Windows operating system installed, right?
Mhm.
Do you remember the olden days where we used to run behind CDs and DVDs and then get the operating system and then install it on our laptops?
Yes, yes.
Right? We don't even have the CD drive nowadays. Nobody,
Nowadays.
some laptops don't even have the pen drive option because everything is over the internet these days.
Yes, yes,
For
yes.
example, in my MacBook, there is no pen drive option.
Oh my God. Okay.
So, like that, now things are evolved. What I'm trying to say is uh, the basic necessity for running anything on your laptop is operating system. Correct? Without that, you can't really do anything.
True.
Okay, that piece we will be doing in the infrastructure as code, which is nothing but infrastructure DevOps. We'll be using Terraform and provision some resources in the cloud. So cloud is nothing but, say, it is just a place where you have resources available but not created, right? Completely. Even
Mhm.
if I say EC2 instance or any RDS cluster or any other EKS cluster, it gives you an option to provision these resources, but you are supposed to create the code and then create the resources like this. Otherwise, it is just a data center which is provided by AWS. You are supposed to create the VPC and necessary resources in AWS cloud and get started. So that
Mhm.
is the first stage for DevOps engineer. First stage for, in fact, I mean, the whole development organization, for the organization who is starting with the development of a new application. So you can see that infra creation, provisioning servers, that is nothing but infrastructure as code. So initially we'll not be directly creating the infrastructure as code. We'll not be using Terraform. We'll be manually creating the resources, and then we'll try to slowly start the coding and then create the infrastructure using Terraform.
Mhm.
So some of the other, see, releasing, right? I told you, till build creation, it is a CI. But once a build is created, it is continuous deployment. It will be consumed by sometimes developers as well, and it will be by QA environment, staging environment, and then pre-prod environment. Have you heard about monitoring? What is monitoring?
Mhm. Like whatever the checks which you have done, we have to keep an eye on that.
Yeah. So basically, if you take your smartphone, right, you will take a look at, I mean, how much disk space it will occupy. If a system is running slow, you will identify what is a utilized RAM, what is a utilized disk space, right? You will go ahead and delete some of the applications or some of the cached files so that your system will be fast. Like that, uh, there'll be a monitoring tool which will be deployed, and then we will configure something to create an alarm or alerts
Mm-hmm.
for a particular metrics. Metrics is nothing but a data which is collected from the running system. Using that, we will try to see whether that is reaching or breaching that threshold or reaching beyond the particular limit, and then send out a notification by email or maybe by sending out an SMS. There are so many other ways to send notifications also. So
Yes,
all of
yes.
these things are part of DevOps. See, DevOps is not just only application deployment. It has so many other responsibilities. Okay.
Mm-hmm.
So some of the things that we'll be learning are some of the things you may have to understand before you start DevOps. Some bit about containerization, some understanding about virtualization. You will have understanding of SDLC already because since you are in the industry for a long time.
Yes.
Uh, you will be learning infrastructure creation tools, some basic understanding of AWS cloud like EC2, S3, because these are the fundamental services that are provided by AWS. What
Okay.
is an application? What is a server? What is a service? What is a process in Linux machine? How do you run multiple processes? How do you make sure the process is running? So many things that are fundamental. So that I'll cover it in the first class uh, before I start explaining uh, other things like maybe Terraform and resource creation in AWS. Okay. So have you ever used a password key-based authentication?
Mm, key
No.
based, no, like,
Public key, private key.
no, no, no.
No. Okay. See, that will be again in our initial one or two classes, creating public and private key pairs, so that we can log into the remote machine without having to type the password. It will be passwordless authentication.
Mm-hmm.
And we'll be heavily using VA editor for uh, editing the files. We'll not be using Notepad. We'll be using VA editor for editing the files, adding new automation. So everything will be through VA editor. We'll be learning a little bit of shell scripting. See, whatever I mentioned, all these commands will be learning part of the DevOps class. So with respect to Python, we'll be learning data structures and control structures. So JSON and YAML is very important for us to carry out some tasks in DevOps. See, JSON is used for uh, creating Terraform code. YAML is used for creating Kubernetes kind of YAML files, Kubernetes YAML files, like pod,
Mm-hmm.
services, deployments, and things like that.
Okay.
Some of the tools that we are using will be learning, that is GitLab, and here it has Docker and Maven. Uh, it will be GitLab CA for release CI/CD. So we'll be learning GitLab CA again for deployment. For operations, we'll be learning Kubernetes. For monitoring, we'll be learning CloudWatch and Grafana. So overall, I mean, these many tools we'll be learning over a period of 45 days.
Mm-hmm.
So some of the positions with respect to our roles and responsibilities with respect to DevOps, you will probably you you will be given just a DevOps engineer when you join a company, when you move into a different organization. But the kind of responsibilities you may go through would be maybe an infrastructure engineer, or you are specific to AWS cloud. You will be doing a lot of resource maintenance or maybe other configurations, kind of a landing zone engineer where you will be performing all the creation of VPC, IAM, and managing the basic infra required. And sometimes you may be an application deployment engineer where you will be closely working with the development team to identify the build requirement, other dependency requirements, other environment related deployments, closely working with developers in this case. Here, infra engineer, you will not be closely working with developers. Uh, you will be an independent engineer who will be collecting requirements from developers and creating the resources in cloud. SRE is all about monitoring and closely working with the customer issues. So there are different kind of roles within DevOps which you probably not aware until you enter into the DevOps role. Any questions?
No, no, I'm good. I'm good.
There is one thing called SLA. Any idea what is SLA? Service level agreement.
Yeah, service level argument. Correct.
Yeah, basically, customers will have some set of requirements, some set of definitions, which says this is a target that I am setting it for you when when I'm giving the service, when I'm asking you to create the service for me, right? They'll say greater than 80% CPU usage is a problem. It's 75% is a warning level, more than 80% is a critical level, and you are supposed to send out a notification. Either all these performance things you need to report it weekly, and everything should be monitored using a monitoring tool. It could be Grafana. They will define what tool that you should be using because depending on what kind of uh, uh,
Mm-hmm.
monitoring they have, what kind of analysis they have, the local tool
Kind of
based on
cloud
that.
watch, right?
Yeah, yeah, we'll be using CloudWatch. So some companies may say it'll be you have to use Grafana, you have to use Datadog. Depending on their requirement, they will suggest the client, they will suggest the company to use it.
Mm-hmm.
So, for example, if you look at the critical level, right? If your response time for a particular operation is greater than 2 seconds for a single operation, you are supposed to send out a notification. You are supposed to create a critical error, critical issue, and then try to address what is happening. If it is repeated for more than 3 times within the last 3 minutes, then it will be a major problem because I mean application is not behaving correctly. The customer may go through a lot of issues. So like that, so we'll be mostly working based on some SLAs given by customer.
Correct. Correct.
So SSH key based authentication, we'll be looking into it. It is based on public and private key, and there is a folder like .ssh folder that is created. You have to run a SSH keygen command to create public key and private key. It is a more secure way of connecting to the remote machines.
Sure. Sure.
Authorized keys. I mean, all these information I'll teach you over the first 1 or 2 classes so that you become familiar with all the fundamentals.
Getting it. Yes.
So how SSH key authentication works, you keep the public key on the remote machine and use a private key to log in, and it does a handshake, and then it sends an echo message checking whether you are the person, you are able to decrypt the particular message. If you are able to decrypt the particular message, then it allows you to log into the remote machine. Basically, it is something similar to your username and password. Username you keep it public, right? Whereas the password you keep it as private. So here, public key is like your username, whereas private key is like your password. That you should keep it always safe and secure.
Yes. Yes.
So, like I told you, we'll be learning GitLab CI, Terraform, Docker, Kubernetes, and the CloudWatch Grafana. So these are all the major tools that we'll be learning over a period of 40-45 days in our class.
Sure. Sure. Sure.
Okay, here is the outcome of your DevOps course. By end of the course, you will be able to do all the Git operations. You will know what are the different features available in GitLab CI, like how to create a pipeline, how to create a build from GitLab CI, what are the different things that you can do it with variables, how do we create environments in GitLab, and you'll be also learning Python. You will be familiar with data types, functions, classes, and exception handling. So ultimately, you will be mostly working with AWS CLI. See, AWS CLI and Terraform, it almost does the same thing, but only exception is Terraform is all about managing the code and putting it in a particular repository. Whereas AWS CLI, uh, random commands that you can run, and have commands you can run, and then do some operations in the AWS cloud. You'll also be learning a little bit of shell scripting to manage some tasks in an automated way. So you'll be learning Docker. You will be uh, you'll be able to Dockerize any application which is given to you after the after DevOps course, and you will have a basic understanding of Kubernetes. You will be able to do some deployments in Kubernetes cluster, and you'll also be doing two projects in this. That is, one is infra DevOps, that is creating a SFTP server, and uh, you will have a server which is running in the AWS cloud. You will be able to transfer files from local machine to the remote machine using that particular server. And
Okay.
another one will be application developers, which is nothing but like I told you, right? I mean, you'll be closely working with the developers. So like that, you will be developing an application, a small application that you'll be hosting in the AWS cloud, and you'll be configuring to work in a highly available, highly scalable, fault tolerant architecture. That is nothing but you'll be using availability zones concept, you'll be using scaling feature, and you'll also be using load balancer for fault tolerant. So all of these you will be learning, and you will be a full-fledged DevOps engineer at the end of the DevOps course.
Sure, sure, sure.
Okay, any questions from your side?
Oh, these other services.
Yeah, basically, these are the services that we'll be learning at a high level. Apart from this, we'll also be learning VPC, we'll also be learning uh, load balancer.
Lambda also you would be teaching, right?
Lambda, maybe I can give you an introduction how we can use it.
Okay. In glue
Lambda,
jobs.
sorry?
Glue jobs.
No, no, no. See, that's what I'm saying. With respect to AWS, right, I will not go very deep. Only
Okay, okay.
whatever is required to deploy that particular application, I'll go through. Okay. Any more questions?
No, no, no. I think I'm good. Yeah.
Okay. I'll just quickly show you the uh, kind of environments I have. So this is one of the GitLab pipeline which is installing. You can see that Kubernetes cluster K8s. I have different stages starting from validate, plan, apply, and destroy. This is how a pipeline will look like for a for creating the infra for running the application.
Mhm.
This is basically for creating a VPC.
Okay.
Did you get a chance to look at the document I shared yesterday? I mean,
Yeah, yeah, yeah. I just
oh,
saw like even like you wrote like 45 days, so 40 to 45 days, and
yeah,
in you have divided into three things where for first 10 to 12 days whatever you have covered you will take a revision or a test like how I have understood what
yeah,
is my level
correct,
of understanding.
correct. So here in this one is public. This repository is public. Here I have, so for 4 classes gone. I mean, I have finished. Uh, for everything, I have the recorded session. If you go to the agenda, you will be able to see what is the thing that I was trying to cover on that particular day. And uh, at the end of the class, I'll keep the video recorded video link.
Yes,
And
yes.
during the class, what you will be doing, that I will mention it in the points, so that you will do it when the class is going on. And I'll be able to help you out for even stepwise. Most of the things are self-explanatory and it is easy to understand. It is also based on the previous class that you have attended. So like that only it will go. It won't be like jumping into a particular set of actions that you are not aware of. But I will make sure before the class I give instructions, and if you probably missed the previous class, I'll try to make sure I give you a separate one-to-one session for you to make sure you get that particular idea how to do it.
Right, right, right.
Okay. Any questions from your side?
Uh, no, no, no. I think I should be good.
Did you get a look at? I
No, no,
mean,
no. I didn't check. No, I didn't check the YouTube. It was. I'm sorry
okay.
for that. Yeah.
Especially the latest video, right? I mean, if you look at it, it shows you how to create infrastructure uh, in the default VPC by writing Terraform code.
Mm-hmm.
I'll share you some of
You
the.
have to refer what other.
I'll share you some more documents to you so that it is basically here itself. See, if you go to this particular all this one, this one has all the documents for you. You can go to October 9 and you will see, uh, sorry, 7th October. Here you can see prerequisites. This document, if you go through, you will be able to understand what you need to do for system preparation.
Mm-hmm.
Okay. You can confirm me or you can talk to me after the class whenever
Sure.
you.
Yeah,
Uh,
yeah.
I'll go ahead and stop the recording for now.
Sure, sure.